So 1 point, hey, if you are doing anything else but paying attention, you may want to fix that behavior. So we have 1.3D properties of functions. Average rate of change is the last piece of 1.3, okay? Average rate of change is what we're going to focus on today. So, calculator move. So the objective here is to find the average rate of change for a function. As you can see, the formula should be given to you, right? So on there, the average rate of change is you're saying if A and B are not equal to each other, and they're all in the same domain, you can find the average rate of change by, what does that look like? What does it look like you're finding?
The change.
The change, triangle means change. Okay. So when I, in the past, I found the change in Y over the change in X, what were we doing? Say it again, Libby. The slope. Average rate of change is another way of calling it slope. Doesn't this look very familiar? The difference is that for average rate of change, you're not working with just a linear, okay? You're working with other functions and you're finding how did it change from one point to the other of that function, okay? Slope is specifically pertaining to a linear function. Does that make sense? If we're saying this is the slope of that linear line. We're talking about the average rate of change though. So from point A to point B, what's happening, okay? So let's dive in and try it. So for example, it says find the average rate of change of f of x equals 3x squared from 1 to 3. Do we see that? Okay, so to do this, step 1, you're going to find the f of x, the f of where it starts. So in this case, where does it start? So we're going to look for f of 1. F of 1 means wherever there's an x, I'm substituting in a 1. So we have 3 times 1 squared, which is just going to be what? 3. 1 squared is 1. 3 times 1 is 3. 2, you're going to find f of where it ends. Where does it end? 3. So now we're doing f of 3, which equals 3 times 3 squared, which is 3 times 9, which equals 27. Questions about step 1 and step 2? Still with me? Yes. All right. Step 3 is to plug in to find the change in the Y over the change in the X. Okay, so we're finding the change in the Y over the change in the X. So I went from 27 over 3, which means it was 3 over 1. Or I could have written it as 3 minus 27 over 1 minus 3. Doesn't matter. What did I get which part from? You gotta be more specific. My numbers came from here. At where did it start? So it said from 1 to 3. Where does it start? At 1. So starts at 1. Where does it end? It ends at 3. So ends is 3. Okay, 27 minus 3 is what? 27 minus 3, 24. 3 minus 1. And so therefore, what is our rate of change? 12. Wow. Okay. What are your questions, comments, or concerns so far? None. Okay, so step 1 is you find your f of starts. Where does it start? Your f of where it ends. Then you use all the values and find the change in your y over the change in your x. Okay. Main thing is, it doesn't matter which one you plug in as long as the numbers are vertically lined up with where they go, right? 3 goes with 27, 1 goes with 3. Same thing here, 3 goes with 1, 27 goes with 3. Do we see that? So they're still lined up. Questions about average rate of change so far? Okay. So then when we look at it graphically, I should have scooted over more. We're saying from here to here, if I was to connect a straight line, not the curve, but a straight line, it would have a slope of 12. Does that make sense? Right now they're connected on a curve, but if I was to connect them with a straight line, it would be 12. Okay? All right, we're going to try it again. I'm going to pause and I want you to find the rate of change from 1 to 5. All right, here we go. So part 1, step 1, you find the f of where it starts. And where does it start at? 1. We've already found that. What did we get? 3. Part 2, you find the f of where it ends. So this is f of 5. I substituted in, have 3 times 5 squared, which is going to equal 3 times 25, which equals 75. Okay. Step 3 is to find your change in your y over the change in your x. So does it matter how I set it up? No, as long as they are vertically lined up. Does that make sense? So if I wrote 3 minus 75 over 1 minus 5, that is okay, right? That gives me negative 72 over negative 4. What's a negative divided by a negative? A positive. What is my rate of change? Is it 18? 4, 1. I have 3 left over. It's 18. I was like, I think that's good. Okay. How do we feel about 1.3D so far? Good? All right. Look here. Use your notebook paper. Use your notebook. That's all I can tell you. All right. So what that means is now if I wanted to draw a line from 1,3 to 5,7, a straight line, it would have to have a steeper slope of 18. Does that make sense? Okay. All right. Do we need to try again or are we okay?
Good.
I think so. Yes, we're good. All right. Yes. Anyone who's like, no? Okay, just to check, I'm going to write it out. So we have f of 1, which is 3. You would find f of 7, which would equal what? 147. And then what would you do? Y'all are walking me through because you say you're good. So what do I do next?
Find your change in your y and then find the change in your x.
I find the change in my y and the change in my x. So that's going to give me 147 minus 3 over 7 minus 1, which gives me 144 over 6, which equals what? 24. Okay, we're all good? All right. Now, yes. All right, so that's the foundation. It's finding the slope. Okay. Now we're going to find the full value of the line. Okay. Does that make sense? To find the whole line, that means we need a y-intercept. Does that make sense? The line that we find is called a secant line. Okay. The line that we find that connects 2 points on a function is called the secant line. Got it? So we're going to find the value of our secant line. Okay. In order to find the value of the secant line, we find the average rate of change, and then we're going to use point slope form. Okay. So we find our points, which we did, and then we connect them. Okay. So we're going to go through the steps. So the first thing you do is find the average rate of change, which we just mastered, right? Okay. And then we're going to find the equation of the secant line. In order to find the equation, we're going to use y minus y1 equals m times x minus x1. Does that look familiar? Point slope? Yeah? Okay. So we're going to do first thing first. Find our average rate of change. So to find the average rate of change here, we're going to have to find f of -2 and f of 1. Agree? So I'm going to find f of -2. And again, I'm going to show you, we've been doing it without a calculator. Have we used a calculator to do anything other than basic computation? No, we have not. So don't freak out on me and say, I didn't have a calculator, miss. We haven't used it, okay? All right, I'm going to use it to plug in. Watch me. Here we go. I'm just going to go to a plain calculator page, and I'm typing in 2 parentheses, -2 squared plus 4 parentheses, -2 minus 3. Can we do that on any calculator? Yes. Hit enter, and I get what? You got what? I got -3.
I got negative.
Did you put your...
Well, negative. Negative. That's what it is.
Oh, I forgot. Okay.
We did it. No, it has been used.
That's okay. I forgot my negative. This is a learning experience of how not to have to type everything. I did it on purpose. Here we go. If you don't want to retype everything, you press second and you see where it says enter. It brings down what you already typed and you can just correct yourself. So I'm going to go over and I'm going to insert a negative. Second, delete allows me to insert a negative and nothing ever went wrong. Bam. I forgot my negative.
Well, that's not real.
I did it on purpose so I can go over how to put the entry in and how to insert. This was like a learning moment. Where were you at? Okay. All right. Good call, Willow. Here we go. -19. Then we're going to do the same thing. Now we're going to find f of, what was our ending? 1. Okay. If you don't want to have to retype all of this, you literally can just go second entry and I can change my -2s to 0s and 1s and save myself a little time. So all I did was second enter, changed my negatives, and then I get my answer. Okay, so instead of retyping it all, what did I press? Second enter, and it brings it back down, and I just change what I need. Because you're not pressing second enter. I don't know. All right. So now I have those. And now can I find their average rate of change? Yes? All right, so step 2, I'm going to keep going, finding the average rate of change. So change in y over change in x is going to give me negative 19 minus negative 1 over negative 2 minus 1. A negative times a negative makes a positive. What is, if you owe me $19 and you give me $1, you still owe me 18. You owe me 2, and you're like, hey, let me borrow another one. You now owe me 3. And a negative divided by a negative is a positive. So our rate of change is 6. Okay, so this 6, this is our slope for our secant line. This is our slope for our secant line. So we found our average rate. Now we're going to find our actual secant line. It does not matter which one of these you let your x1 and y1 be, but I usually choose the one with the smallest numbers. So I'm going to let this one be x1 and this be y1 because it's smaller. I mean, if you want to work with 19, I will not stop you. Okay. So now we're going to do the part, I should have called this A, sorry. Now we're on part B. So part B, we're going to plug in what we have. We have our M, we have an x1 and a y1, and we just have to solve for y. If you wanted to go ahead and get y by itself, what am I going to end up doing with this y1? I'm going to end up adding it. So I can just go ahead and make sure that it's already. So y equals, what's our slope? 6 times x. What's our x1? 1 plus our y1, which is negative 1. I clean this up, and I'm going to have y equals 6x minus 6 minus 1, which is negative 7. Y equals 6x minus 7. And that is my secant. Because we put it in simplified form.
You don't actually.
Okay. So let's talk about what we did. So part A, it says find the average rate of your change from -2 to 1. So we found the average rate of our change from -2 to 1. Yes? Are we good with that? Part B is the new part where we're actually finding the equation of the secant line. Okay, we find the equation of the secant line using point slope form. That's because I can choose either this point or this point, and I have found my slope. Yes, I plug everything in where they go. I put in my slope, my x1 and my y1, and then I simplify. And here's the equation of my secant. So if I did this correctly, when I graph this on the calculator, when I graph g of x, I'm going to go here, and I'm going to, I already had it in there. Why? I did it. 2x to the third squared, sorry, that is not a 2. 2x squared plus, and I forgot the negative again. The negative plus 4x minus 3. I hit graph. It's going to look weird because my window's not right and I didn't reset my calculator. That's okay. Little shortcut window. You see what, I'm sorry, zoom. You see where it says standard? If you go to zoom standard, it's going to automatically reset your window to its original settings. Okay. And then I'm going to graph my secant line. So I'm going to go back to y equals, and in my y2, I'm going to put in 6x minus 7. 6x minus 7. And when I hit graph, it should create a line that goes through it. So as long as I did this correctly, I either can look on the graph, but I prefer to look on the table. If I go to the values of -2, they should be the same. Are they the same? Is it the same? This is how you check yourself. So if I go to -2, they're the same. Perfect. If I go to 1 and they're the same, perfect. So what does that let me know I did? I did it right. If those values are not the same, then I did something wrong and you need to fix it. Why is it -2? Because what was the starting point for our average rate of change? And what was the ending point? 1. Okay. So that's what the calculator part is there for you to check yourself. But did we use the calculator for anything else other than to check ourselves? No, we did not. Okay. All right. All right, so you have the exit ticket. We will go over your exit ticket as you're due now tomorrow to see how we did and if you can do it from start to finish. On your exit ticket, you are just finding the average rate of change for the first one, but you're finding the full secant line for the second one, okay?